Okay guys, so in the second guided practice problem, we are going to follow through our steps again. So the first step was to label our given. So let's read through this problem together, and this time I'm going to label them P, V, T, and then I'm also going to label the number, like 1 or 2. So it says an airtight container with a volume of 4.25 times 10 to the 4th liters and an internal pressure of 1 atm and an internal temperature of 15 degrees C is washed off the deck of a ship and sinks to a depth. So here's our action. This is the change. Okay, so this container is dropped into the ocean. So that is the change. So anything before the change are all ones. So this is liters, so this is volume 1. This is ATM, so this is pressure 1. And this is degrees C, so this is temperature 1. I'm going to go ahead and stop and convert this temperature to Kelvin. Okay, so remember we always add our 273 to Celsius to get Kelvin. So this is really 288 Kelvin. Okay, so I keep reading. Sinks to a depth where the volume is this many liters. So this is the volume after the change. So this is volume 2. The pressure is 6 atms. This is P2, and then it's asking for the temperature, so this is going to be T2. In this problem, I double check, are all of my units the same? Do I have the same pressures? Okay, pressures in ATM, pressures in ATM, I'm good. Volumes in liters, volumes also in liters, so I'm good. My units are the same, and I did convert my temperature units. So now I'm ready to plug my numbers in. So what I'm going to do now is I'm going to write my formula, P1 V1 over T1 equals P2 V2 over T2. And P1 is 1 atm. V1 is 4.25 times 10 to the 4th. T1 was 288. And now I do P2. P2 is 6. V2 is 1.03 times 10 to the 4th. And we're trying to solve for T2. Whenever you're solving for temperature, you can cross multiply and divide. But before you can do that, you have to simplify the numerators, because right now there's 2 numbers, and you can really only cross multiply and divide when there's 1 number. So I'm going to multiply these 2 numbers together, which just gives me 4.25 times 10 to the 4th divided by 288. Okay. So that's the first fraction. And my second fraction, I need to multiply 6 times 1.03 times 10 to the 4th power. And it gives me 6.18 times 10 to the 4th power. And then it's divided by T2. So now I'm going to cross multiply and divide. So I'm going to multiply these 2 together, and then I'll divide them by the 4.25. So I have 288 times 6.18 times 10 to the 4th. And then I get a really big number, so I'm going to divide that number by 4.25 times 10 to the 4th. Bless you. And I get, my temperature is 418.8 degrees Kelvin. And how did I know it was Kelvin? Well, remember, your units are always the same. So if my first temperature was in Kelvin, which it was, then my second temperature is also going to be in Kelvin. The next 2 practice problems I'm going to show you, we're not going to have the units for every single like pressure, volume, and temperature. In these, it specifically says that some of them are held constant. If anything's ever held constant, it means you can basically erase it from your equation. So when we're reading this one, it says we have 5 liters of gas, this is volume, collected at 100 Kelvin, that's temperature. Then it's allowed to expand, so that's my change. So anything before the change are 1s, so V1 and T1. This would be our V2, okay? And then what's the new temperature? So we're looking for T2. It says pressure's held constant, so that means we do not have to use P1 or P2 in our formula. So you know how it's P1 V1 over T1 equals P2 V2 over T2? I'm essentially going to cross out my pressure. We don't even need it. So really we're doing V1 over T1 equals V2 over T2. So V1 is 5 liters. I'll just take off the liters, 5. T1 is 100. V2 is 20, and T2 is what we're looking for. And all you do is cross multiply and divide to solve for this one. This one was a pretty easy one because our volume was in the same units. Remember, if they're in two different units, you have to convert them to make sure they're the same unit. Doesn't matter if they're liters or milliliters, they just have to be the same. And our temperature here happened to be in Kelvin, which is good, because if it was in something else, we would have to convert it to Celsius first. And I'll leave you to solve for this answer on your own, but it's just 100 times 20 divided by 5. So our last problem, guided practice number 4, we have something else held constant. If you ever see this, by the way, if you ever see this term isothermal means that temperature is constant. So basically you could take temperature out of the equation. Something else I want to mention, if you ever see STP, remember that that would mean your temperature is 0 K and your pressure is 1 atmosphere. Okay, in this one it says we have a balloon filled with 35 liters in the morning, and the temperature is 20 degrees Celsius. So let's change that right now. I added 273, so there's my Kelvin. By noon, the temperature has risen. So this is my change. So that means anything before it is my 1. That's V1 and T1. The temperature's risen to T2. What's the new volume? So we're looking for V2. Oh, and I need to change this number to Kelvin. So I take 45 and I add it to 273. I get 318. That's T2. What's the new volume of the balloon? Did it mention anything about pressure in this? It didn't. So if it doesn't mention anything about a variable, if it doesn't mention volume at all, if it doesn't mention temperature at all, if it doesn't mention pressure at all, then again, you can cross it off like we did up here. And so this problem is the same. It's just V1 over T1 equals V2 over T2. And so if we solved for this, you would see that you have 35 is volume 1, 293 is temperature 1. We're looking for V2, and then your salt, and then temperature 2 is 318. So again, we would just be cross multiplying and dividing to get your V2. And now I'm going to have you do the on your own problems on your own. And that's it for today. You'll have a fantastic day. And say hi to my roommate and my husband.
Hi guys.